Hello everyone. In this video, we are going to discuss about thermodynamic state variables from the chapter 11 Thermodynamics, class 11 Physics. We have discussed a few concepts from this chapter in our previous videos which are available in the playlist. So, thermodynamic state variables, these are the physical quantities that define the state of thermodynamic system in equilibrium. These variables provide a complete description of the system's properties and behavior. So, thermodynamic state variables are the physical quantities that define the state of thermodynamic system in equilibrium. Now, you see, when we consider thermodynamic state variables, these are broadly categorized into two types. One is intensive variables, another one is extensive variables. So, thermodynamic state variables can be categorized into intensive variables and extensive variables. Okay, now what are intensive variables? Intensive variables are independent of the size of the system. Intensive variables are the thermodynamic state variables which are independent of the size of the system or mass of the system. That is, they remain the same regardless of the amount of substance in the system. Some examples for the intensive variables are temperature, pressure, density, etc. You see, temperature is an intensive thermodynamic state variable. Why? Because temperature does not depend on the size or mass of the system. It actually reflects the average kinetic energy of the particles in the system. Adding more matter to the system increases the total energy but does not change the average energy per molecule. So, temperature remains unchanged. So, temperature does not depend on the size of the system, so it is an intensive variable. Similarly, if a system is divided into smaller parts, each part will have the same temperature as the whole system. That is, splitting a container of gas into two halves does not change the temperature of either half. So, temperature, it is independent of the size of the system or mass of the system. So, temperature is an example for the intensive thermodynamic state variable. Okay, now another next one is extensive variables. See, extensive variables, they depend on the size of the system. So, extensive variables are the variables which depend on the size of the system or the amount of substance. That is, if we divide a system in equilibrium into two equal parts, these extensive variables whose values get halved in each part are extensive. I mean, if we divide a system in equilibrium into two equal parts, the variables whose values get halved in each part are called, they are extensive. Some examples for the extensive variables are internal energy, volume, mass, enthalpy, entropy, etc. For example, suppose we are considering a system of mass m and volume v. We have a system of mass m and volume v. Suppose this system is divided into two equal halves, two equal parts. Then its mass, this part will have the mass m by 2 and this part will have the mass m by 2. And you see the volume also reduced, no? This part will have, this half will have the volume v by 2 and this half will have the volume v by 2. Okay, so here mass and volume changes. Okay, so you see initially the mass and volume were m and v. When we divided them into two equal parts, their size becomes different. Okay, and the mass and volume, that is also different now. They are also different now. So you see, mass and volume, they depend on the size of the system. When the size was this much, mass was m and volume was v. But when the size is only this much, mass is m by 2 and volume is v by 2. So mass and volume are extensive variables. So the variables which are independent of the size of the system are intensive variables, and the variables which depend on the size of the system are extensive variables. Temperature, pressure, density, etc. are intensive variables. Then internal energy, volume, mass, enthalpy, entropy, etc. are extensive variables. So in this video, we have discussed about the thermodynamic state variables, that are intensive variables and extensive variables. I hope it is clear to you. Thank you.